Looking at this evolutionary ladder, step 1 was the basic request-response loop. Step 3 reached agents fetching data from isolated tools. Reaching step 5 requires a new architecture, an environment designed to govern autonomous work where models dynamically route tasks and orchestrate subagents. This comparison highlights a divide in how open-source developers approach the problem. On the left, OpenClaw aims to be a personal assistant gateway, bridging text threads across various messaging apps. On the right, Hermes version 0.11 provides a deeply programmable execution layer. This release drops the assistant label. Hermes functions as an operating panel, a model routing control center for multi-agent execution. Consigning an AI to a chat window limits its utility. To complete real work without a human in the loop, you have to pilot the AI like a complex machine rather than talking to it like a chatbot. The React and Ink terminal interface provides the visibility needed for the shift. When an agent is editing files or calling tools autonomously, you need a structured layer to monitor those actions without guessing what is happening in the background. Specialized tasks require different models. A single workflow might need a reasoning model to plan code, a faster model to summarize logs, and a dedicated vision model to interpret screenshots. The pluggable transports layer handles this. The Hermes dispatcher routes tasks dynamically to providers like GPT 5.5, Claude, or AWS Bedrock. Providers handle streaming and tool calls differently. The transport layer manages format conversion, isolating mechanical differences so the system swaps models on the fly. But even with the right models, parallel execution is fragile when multiple subagents work at the same time. They frequently fail by repeating tasks or overriding each other's edits in shared project files. Hermes addresses this by enforcing an explicit orchestrator hierarchy. The system assigns tasks and controls the spawn depth of worker agents, while a strict file system coordination layer locks file access to prevent subagents from destroying each other's progress. The barrier between a developer's experiment and a reliable execution engine is this specific transition from isolated prompts to coordinated delegation. Even coordinated agents experience drift. A model may misinterpret one instruction and spend several minutes pulling irrelevant data, consuming time and API tokens. To fix this drift, Hermes uses a steering command. The user injects a nudge that redirects the agent's trajectory immediately after its next tool call. This preserves the prompt cache and context window, lowering latency and token costs for the rest of the execution loop. However, giving an AI the tools to execute tasks creates risk. An autonomous agent that can browse the open web or run arbitrary shell scripts is a massive liability without constant oversight. The plugin ecosystem serves as a governance mechanism to manage this. The core runtime uses protocol hooks to intercept and block risky actions, allowing developers to enforce approval logic before the tool ever executes. The ability to steer an agent mid-flight and veto its actions is what allows an autonomous system to be used reliably for real work. This workflow loop connects the platform's features into a daily life cycle. An operator initiates the task, the system routes it to the correct model, delegates to subagent, allows the user to steer the work, governs tool execution, and tracks costs. Running this loop directly on a local file system is a hazard. Connecting an autonomous agent to external platforms and shell commands creates vulnerabilities that must be managed through isolation. Hermes supports 6 execution backends to address this. For secure work, operators can use Docker containers or cloud virtual machines to enforce strict namespace isolation, PID limits, and rigid boundaries for untrusted code. This comparison shows the requirement for discipline. While the platform provides the tools for orchestration and routing, it demands caution to prevent an agent from causing a cascading failures across your system. Each audience quadrant inherits specific benefits and burdens. Developers gain runtime control while businesses get explicit orchestration, but both must handle the security of extension points and the risks of credential management. Scaling an agent beyond a single prompt requires a system that handles the logistics of routing and safety. By integrating model provider abstractions with subagent orchestration, Hermes v0.11 moves the focus from the model's intelligence to the operator's ability to govern the process.